Speed is a measure of how fast an object is moving, and it is usually expressed as the distance traveled per unit of time. The standard unit of speed is meters per second, meter per second, or kilometers per hour, kilometer per hour, although other units such as miles per hour, mph, or feet per second, foot per second, are also commonly used. Speed is a scalar quantity, which means that it only has a magnitude, size, and not a direction. For example, if a car is traveling at a speed of 60 km per hour, it is simply moving at a rate of 60 km per hour, but the direction in which it is moving is not specified. It's important to note that speed only tells us how fast an object is moving, but it does not provide any information about the direction of motion or any changes in direction that may occur. To fully describe the motion of an object, we need to consider other quantities such as velocity, which is a vector quantity that includes both the speed and the direction of motion. To solve for speed, you need to know two quantities: the distance traveled and the time taken to travel that distance. The formula for speed is speed equals distance time. So to solve for speed, you need to divide the distance traveled by the time taken to travel that distance. Here's an example problem. Q. A car travels a distance of 100 km in 2 hours. What is its speed? O. Using the formula, we have speed equals distance, time speed equals 100 km, 2 hours speed equals 50 km per hour. Therefore, the speed of the car is 50 km per hour. It's important to ensure that the units used for distance and time are consistent. In the example above, both distance and time were in kilometers and hours, respectively, so the resulting speed was in kilometers per hour. If different units are used, they will need to be converted before the calculation can be performed. Here are some examples of speed problems. Example 1. A person walks a distance of 500 meters in 5 minutes. What is their speed in meters per second? Solution. First, we need to convert minutes to seconds, since speed is measured in meters per second. 5 minutes is equal to 300 seconds. Then we can use the formula for speed. Speed equals distance, time speed equals 500 meters, 300 s speed equals 1.67 meters per second. Therefore, the person's speed is 1.67 meters per second. Example 2. A car travels a distance of 200 miles in 4 hours. What is its speed in miles per hour? Solution. We can use the formula for speed directly, since both distance and time are in the same units. Speed equals distance, time speed equals 200 miles, 4 hours speed equals 50 miles per hour. Therefore, the car's speed is 50 miles per hour. Example 3. An airplane travels a distance of 3,000 kilometers in 2.5 hours. What is its speed in kilometers per hour? Solution. We can use the formula for speed directly. Speed equals distance, time speed equals 3,000 kilometers, 2.5 hours speed equals 1,200 kilometers per hour. Therefore, the airplane speed is 1,200 kilometers per hour. Here are some key things to remember about speed. 1. Speed is a measure of how fast an object is moving, and it is usually expressed as the distance traveled per unit of time. 2. The standard units for speed are meters per second, meter per second, or kilometers per hour, kilometer per hour, but other units such as miles per hour, mph, or feet per second, foot per second, may also be used. 3. Speed is a scalar quantity, which means that it only has a magnitude, size, and not a direction. 4. To calculate speed, you need to know the distance traveled and the time taken to travel that distance. 4. The formula for speed is speed equals distance, time. 5. It's important to ensure that the units used for distance and time are consistent. 6. If an object is changing its speed or direction, its motion cannot be fully described by speed alone. 6. In this case, we need to consider other quantities such as velocity and acceleration. 7. Speed is a relative quantity, which means that it depends on the observer's frame of reference. 7. The speed of an object may appear different to different observers, depending on their relative motion.